Hi, this is Richard C. I'm a math tutor here at Wyzant and answering a question submitted by a student. This question is probably coming from pre-calculus, which is where you tend to learn about radians and related topics. This question uses a very well-known formula that's kind of important to remember. It's used quite a lot in pre-calculus. I'm just going to draw a diagram here, and we're going to create a sector in this circle here. And this is the center of the circle. I tell my students to think about a slice of pizza, which is one of my favorite things to eat. So we have an angle. This is a central angle, theta. Just move this stuff back. Not really sure. This sort of thing is not supposed to happen, but it does happen once in a while. Okay, so here we are back here. Okay, so here's our central angle, theta, and here is the radius of the circle, and this is the center here. And the formula is, which is quite well known, S is equal to r theta, where S is the arc length. In fact, this formula is the way we often introduce radians to students. So that's your S there. Okay, cleaning that up a little bit, and we're all set. All right, so now we'll just apply the values that were given here. So given that the length of a sector with radius 4, so the radius is 4, so we'll put the 4 here. And the arc length is 3, so we'll put the 3 here. They want to know how big theta is, and so we'll put the theta here. And you can see I'm just matching this up. The theta is theta, r is 4, and the length, the arc length, is 3. So the answer is 3/4 radians. And that's all there is to it. So this is an important formula, so I would suggest that you memorize this. There's an equivalent, there's a similar formula for the area of a sector. This piece of pizza, the slice of pizza, is called a sector. So you might not have been familiar with the vocabulary here. So there are two formulas, one for the arc length, which is the one that's used most often, and then the other formula is for the area of the sector. You would have studied these in geometry, but the angles would have been measured in degrees. Okay, so that's it for this problem. Nice and simple, assuming you know the formula. Okay, see you again next time. Bye-bye.